About the size of a teacup, the venomous species of the cane toad has been thriving in Australia since 1935, when they were introduced from Hawaii in an attempt to control the population of the native cane beetle. However, they turned out to be failures at controlling beetles, but they are very successful at reproducing and growing at an exponential rate because there are no natural predators, they breed easily, and there is an abundant supply of food, mostly in the form of pet food left outside. Seen as pests, the Australian government has ordered their citizens to collect and dispose of any cane toads they find. With their population now estimated to be 2 billion, how long will it take for the cane toads to take over the continent of Australia and eventually the world?
If the population of cane toads is currently at 2 billion and they have a growth rate of 34% per year, how many cane toads will be there after 5 years? A model equation we could use for the cane toad's exponential growth would be y is equal to a times 1 plus r to the t power, where y is the final amount, a is the initial amount, r the growth rate, and t is the time in years. Let's plug the values into our model equation to solve for y. Y is equal to 2 billion 1 times 1 plus 0.34 to the fifth power. To solve for y, find the multiplier by adding 1 and 0.34 to get 1.34 and raise it to the fifth power to get 4.3204. Next, multiply this number by 2 billion and finish solving for y. The final answer is 8,640,800,685 cane toads. To find the x value, we can use the same equation but a slightly different process to solve. For example, we will use the situation, how long will it take in years for the population of cane toads to reach 14 billion? Again, we will model this scenario using the equation y is equal to a times 1 plus r to the t power, but use natural logarithms to solve. Plugging in our values, here's our equation. 14 billion is equal to 2 billion times 1 plus 0.34 to the t power. First, divide both sides by 2 billion to get the equation. 7 is equal to 1 plus 0.34 to the t power, which may be simplified to 7 is equal to 1.34 to the t power. Using the power property of logs, bring the t down in front of the 1.34. Now, in both sides, make the equation look like this. ln of 7 is equal to t times ln of 1.34. Divide both sides by ln of 1.34 and get your final answer for t, which is 6.6488 years.
For our graph, we have chosen to put the total time in years on the x-axis and the cane toad population in billions on the y-axis. After 1 year, there will be 2.68 billion cane toads. After 2 years, there will be 3.6 billion toads. After 3 years, it will grow to 4.8 billion. Another year later, there will be 6.4 billion toads. After 5 years, there will be 8.6 billion cane toads. After 6 years, there will approximately be 11.6 billion, and after 7 years, there will be 15.5 billion cane toads. In 7 years, cane toads will completely infiltrate Australia.